New York built towers that looked like another century, but 432 Park Avenue pushed the idea of a skyscraper into something.
New York has built towers that look like they belong in another century, but 432 Park Avenue pushed the idea of a skyscraper into something much thinner. At 1,396 feet, it rises more than a quarter of a mile above Manhattan, yet its exposed white concrete frame is only about 93 feet wide. Engineers call that kind of proportion exceptionally slender. And by 2025, inspectors were documenting hundreds of cracks, concrete deterioration, and missing pieces of material on its fade. Structural engineer Steve Buongiorno has said the building is being stressed beyond what was intended, while other experts have pointed to its extreme height, slenderness, and exposure to wind. The building is safe, according to city officials and inspectors. This is 432 Park Avenue, and the problem isn't fixed. The tower began with a very New York ambition. Take one of the world's most valuable pieces of real estate and build upward, very far upward. Developer Harry Mack Lowe and Sim Group wanted a residential tower that could turn limited Manhattan land into an extraordinary amount of vertical space. The architect was Raphael Vinoy, working with Sulce Architects as executive architect, while Wesp handled the structural engineering and Lindley served as the contractor. The brief wasn't simply to make another luxury apartment building. It was to create an object that would dominate the skyline, while giving its residents enormous views of Central Park and Manhattan. Vinoy's answer was almost brutally simple. A square tower, a regular grid, exposed concrete, huge windows, and almost no visual clutter. Construction of the foundation began in 2011, above-ground construction followed in 2012, and the tower topped out in October 2014. It was completed in 2015. The result was extraordinary. 432 Park rises about 1,396 feet, or roughly 425 meters. CTBU records 85 actual floors, although the building's marketing and floor numbering have long described it as a 96-story tower. There are 104 residences, including enormous penthouses, with interiors designed around 10 by 10-foot windows and ceilings, more than 12 feet high. At completion, it was the tallest residential building in the Western Hemisphere. The structure itself is unusually pure. The tower is divided into 7 stacked sections with open mechanical levels between them. Those gaps aren't decoration. They allow wind to pass through the building instead of pushing continuously against one solid wall. And then the engineers started doing the math. At this height, the problem isn't simply holding the building up. It's controlling how the building moves while people are living inside it. In a normal building, wind pushes against a structure, and the structure moves slightly. The taller and thinner the building becomes, the larger that movement can become, and 432 Park took that relationship almost to an extreme. Here's the thing about 432 Park that every tall building engineer knows. A skyscraper doesn't have to be perfectly rigid. In fact, it can't be. Tall buildings sway. That's normal. The question is, how much, how quickly, and what happens to everything attached to the structure when it moves? 432 Park's height-to-width ratio is roughly 15:1. That makes it extraordinarily slender for a building of this height. The square plan helps, and the large openings between sections reduce wind forces, but the building still has to deal with enormous changes in pressure as storms move around Manhattan. That is where the tuned mass dampers enter the story. The tower uses 2 tuned mass dampers near the top. These are enormous moving masses designed to respond to the building's motion and reduce the amount of sway occupants feel. Think of them as controlled counterweights. When the tower moves one way, the masses move in a way that opposes part of that motion. It sounds simple. It isn't. Because movement doesn't stay outside. When a building sways, Elevators have to tolerate it. Pipes have to tolerate it. Interior partitions have to tolerate it. Mechanical connections have to tolerate it. And a fade made from exposed concrete has to tolerate repeated changes in temperature, moisture, and structural movement. Let's talk about what happens structurally when you combine all of those things. Concrete naturally develops cracks. That alone isn't evidence of an unsafe skyscraper. But when cracks allow water into places where it shouldn't go, another process can begin. Steel reinforcement inside concrete can corrode. When steel rusts, it expands. That expansion puts pressure on the surrounding concrete, which can create more cracking and eventually cause pieces of concrete to break away. That's called spalling. At 432 Park, the fade itself became a central part of the dispute. The tower's white concrete appearance was one of its defining architectural features. But producing large quantities of very white structural concrete at this scale created technical challenges. Documents reviewed by the New York Times showed engineers debating concrete mixes during construction, including concerns about using materials that could darken the final color. One 2012 exchange captured the dilemma particularly well. Engineers were effectively being forced to choose between appearance and cracking resistance. Not slightly. Not as a design flourish. The concrete had to perform structurally while also producing the exact appearance the architects and developers wanted. The engineering response didn't end when construction finished. The tower's fade contains roughly 248,000 square feet of exterior wall area. In close, the fade contractor installed 1,823 window wall units over 18 months. Each floor has a highly repetitive grid with 24 punched window openings. That repetition is part of the tower's strength and part of its vulnerability. A building like this has thousands of connections between different materials and systems. Concrete moves differently from glass. Metal moves differently from concrete. Pipes move differently from all of them. And wind doesn't care whether the apartment below belongs to a billionaire. But here's something about this building that nobody ever explains. The problems residents noticed weren't limited to cracks. They heard the structure. Residents reported creaking, banging, and clicking sounds during high winds. Some described vibrations that made sleeping difficult. Elevators could slow down or shut down when the tower moved significantly in strong winds. And then there was water. In November 2018, 2 separate leaks caused serious disruption. One occurred around a high-pressure water connection on the 60th floor. 4 days later, another waterline failure on the 74th floor allowed water into elevator shafts, taking 2 of the residential elevators out of service for weeks. Water also damaged apartments. Court records describe 35 units affected by water infiltration. That part doesn't make it into the architecture magazines. The incident that turned the complaints into a much larger public story came later. On September 23, 2021, the 432 Park Condominium Board filed a lawsuit against the developers, alleging more than 1,500 construction and design defects identified by an engineering consultant. The allegations covered plumbing, elevators, electrical systems, noise, vibration, and other building components. The financial claim was enormous. The board sought at least $125 million in damages in the amended case, while contemporary reporting also described a broader claim reaching $250 million when other damages were considered. The developers rejected the characterization of the building as fundamentally unsafe and argued that many complaints were exaggerated or related to ordinary maintenance and closeout work. Nobody was injured in the incidents described in the lawsuit. But here's the detail nobody surfaces. A tower can remain structurally sound and still have a serious serviceability problem. Serviceability is the everyday question. Can the elevator operate? Can the plumbing survive? Can the windows remain sealed? Can residents sleep? And can the fade continue doing its job without constant intervention? That distinction matters. New York has seen other skyscraper engineering scares. The Citicorp Center discovered a major wind design problem in the late 1970s and was secretly strengthened before a disaster occurred. The Empire State Building has undergone fade inspections and removal of loose material during its long life. And newer supertalls, such as 157 and other Billionaires Row towers, have had their own disputes over wind, water, and building performance. Here is the fundamental difference between 432 Park and every other supertall we've covered. Its defining architectural idea isn't hidden inside the building. The extreme slenderness is the building. The height is the building. The exposed concrete is the building. And the fade cracking, now being documented, is happening directly across that same system. By 2025, reports reviewed by the New York Times described hundreds of cracks, along with areas of spalled concrete, honeycombing, surface voids, and missing chunks on different floors. Engineers have warned that continued cracking could allow more water penetration and contribute to deterioration. But the city's position remains important. Inspectors have not concluded that the tower is on the verge of collapse. In 2025, the New York Times reported that an engineering report described the building as being in fair condition and stated that unsafe conditions no longer existed after urgent fade work. So the unanswered question isn't, will it fall? There is no evidence to make that prediction. The harder question is what happens when a very young superdoll develops deterioration that engineers already have to spend millions of dollars managing. There is no historical data for what a 196-foot, ultra-slender residential tower looks like at 50 years, because no comparable building is 50 years old. This is the first. It is the only one. Think about what that means for 2065. The engineers reading the inspection records then won't be studying a theoretical structure. They'll be studying the accumulated history of every repair, every crack, every water leak, every cycle of wind and temperature that 432 Park experienced during its first half-century. That data will matter, because materials age, concrete can shrink and crack, steel can corrode, sealants can deteriorate, mechanical equipment can wear out, and a building that was engineered precisely enough to reach 1,396 feet doesn't stop aging simply because the mathematics were correct on opening day. But here's the question that sits beneath all of this. What does luxury look like when the most expensive part of your apartment is also a machine moving in the wind? Residents at 432 Park still have extraordinary views. The apartments have 10-foot square windows. The building has a 75-foot indoor swimming pool, private restaurant facilities, and more than 30,000 square feet of amenities. People still live there. They wake up above Central Park. They walk across polished floors. They look through enormous windows at traffic hundreds of feet below. Somewhere inside, a resident can hear the faint movement of the building during a windy night, while someone else is probably complaining about a plumbing repair. And somewhere below, maintenance workers are dealing with the ordinary things that keep an extraordinary building functioning. A pipe joint. An elevator. A concrete crack. A seal. None of them are thinking about the fact that this tower was built to test how far a residential skyscraper could be pushed upward while remaining comfortable enough to call home. Right now, someone is riding an elevator inside 432 Park Avenue, looking out at Manhattan and thinking about dinner, work, or the view. They probably aren't thinking about concrete chemistry, fade inspections, or structural damping. And that's the strange part. The building is still standing. The engineering still works. The question is simply how much work it will take to keep it that way. Drop it below. Would you buy an apartment in 432 Park Avenue, knowing what we know now? See you in the next one. Verify 432 Park Avenue residential skyscraper at 432 Park Avenue, Manhattan, New York. Raphael Violi, design architect. Sliss Architects Executive / Architect of Record. Bois Cantor Sinuk Structural Engineering. Lindley's General Contractor. Sim Group and Maclo Properties Developer / Client. Construction foundation began 2011. Above ground construction began 2012. Topped out October 2014. Completed 2015. Height approximately 1,396 feet / 425.5 425.7 meters. Actual floor count 85 above ground according to CTBA. Marketing / floor numbering commonly described as 96 stories. Residential units 104. Height to width ratio approximately 15:1. Tower width approximately 93 feet. Window dimensions approximately 10 by 10 feet. Fade area approximately 248,000 square feet. Window wall units installed 1,823. Window wall installation period 18 months. Window openings per floor 24. Tuned mass dampers 2. Used to reduce building motion. Amenity space more than 30,000 square feet. Indoor swimming pool 75 feet long. November 22, 2018 water leak associated with a high-pressure water connection around the 60th floor. November 26, 2018 waterline failure around the 74th floor affected elevator shafts. 2 residential elevators reportedly out of service for weeks following the 2018 water incident. 35 units described in court records as having suffered water damage. September 23, 2021, Condominium Board filed its lawsuit against the developers. More than 1,500 construction and design defects alleged by the Condominium Board based on an engineering consultant's investigation. At least $125 million damages sought in the amended lawsuit. $250 million broader damages figure reported in contemporary coverage of the 2021 lawsuit. 2025 New York Times reporting documented fade cracking, spalling, honeycombing, surface voids, and missing concrete. 2025 An engineering report described the building as in fair condition and stated that unsafe conditions no longer existed after urgent fade work. 2065, a future 50-year reference point calculated from the building's 2015 completion.all claims concerning alleged defects, resident complaints, lawsuits, and deterioration are allegations or reported findings unless explicitly attributed to inspectors. Court records or engineering reports. Please subscribe to my channel if you want.